And I think now we're recording. Hey, how are you? Good morning. So I think Brandon's here. Hi, Brandon. Hey, good morning.
Good morning. Sorry I'm late.
That's okay. Did you guys meet Brandon at MozFest? He was at MozFest. I don't know if either Christy or Bruno ran into him there. Maybe not.
I don't know, and I can't see you.
Maybe we don't have the video.
Yeah, he's
Yeah, sorry. Hold on a minute.
not required, but
I did. Kristen shared the session I did. Whatever.
Oh, cool. Nice. Yeah,
There,
I
that's
recognize you.
you don't have to keep your video on if you don't want to.
No, sorry, I was just at a conference.
All right, so I know Sonal requested to join the call, and she's our other regular on this call, so we'll wait just a second to see if she shows up. And then Yusuf is usually here, but he sometimes has connectivity problems. So in a second, I'll just ping Sonal and see if she's joining. Oh, something got dropped on her lap this morning. She has 2 part-time jobs. Yeah. Okay. All right. So she's not going to be here. Sorry, you guys. And then I don't know what's up with Yusuf. Let me just see if he accepted the meeting invite. If not, it's going to be a very special, intimate. He did accept the meeting invite, so he may be here eventually. But for now, let's just get started. And we're recording this session for anyone who missed it. So yeah, so Bruno and Christy, you maybe know Brandon. Brandon, do you just want to introduce yourself and remind everybody where you're from and what you're doing?
Yeah. Sorry. Still working on coffee. Yeah, so I'm Brandon. I'm at CABI, the Center for Agriculture and Biosciences it's in a small town in between Reading and Oxford. So it's called Wallingford. Not that I expect anybody to ever hear that. Anyway, so but what I'm working on is sorry, how much do you need?
That's just go ahead. You're the only one here, so we'll get to know each other.
Earth science and GIS and sort of and then I started moving into sort of semantics and ontologies. And so for the study group, I guess that's probably what's pertinent here. For the study group, one of the things is there's a lot of landmines in that area. It's a bunch of logic and it's a mixture of like logic, philosophy, coding, a whole bunch of stuff, right? And then there's a lot of landmines. So in your sciences, the idea was to have a study group for those people that are interested in learning how to create those types of models, whatever level of specificity or logic you want to have. So there's a
Oops. Yeah, he froze, but I'm sure he'll come back. I will just chat him and let him know that he froze. Oops, I spelled his name wrong. And I'll chat him in the pad too. Okay. So the other thing that we do on these calls is on line 81 on the Etherpad, there are goals from the previous week, and I believe Brandon is on line 83. And so I'm just going to copy paste his goals up to the top under line 16. And when he comes back on, and I hope he's not like out there somewhere just talking. Well, he's frozen. But I'm gonna post. Oh, there he goes. Okay, well maybe we'll come back. I posted his goals and we'll check in on those when he comes back. And so and thanks you guys for being on here. I'm sorry attendance is so poor. We're recording the session so people will be able to watch it. And
It's an intimate stuff.
yeah, very very intimate session. But Brandon is here and will return, I believe. Let's see. I don't think I have to. Yeah, I don't think I have to
Can I ask a
re-invite him.
question while we're
Yeah, go ahead.
So this, who is invited to this? Are these people who want to start a new study group?
Yeah, they are. And oops, that's the wrong tab. But I'm gonna put in the Etherpad also. Uh, at the top under the just above the roll call, the link to the other Etherpad for the North American one, which was much more active. Like we have 4 or 5 people there. So we're trying to get people. This is the first time we've done it this way too. Like normally with the study groups, we just have the repository which anyone can fork. And I don't know if either of you have seen that or looked at it yet. And then there was a handbook that Bill had written, which is like web-based, but the organization of the handbook, we just felt couldn't use a little more improvement. It didn't have any sections on open science. It assumed quite a bit of GitHub knowledge. And the materials about teaching were separate from and facilitating were separate from the handbook themselves and sort of linked in another repo. And so we reorganized that, put a lot of stuff together. We made that section, a whole section on open science. And then and then we decided, oh, we'll also have these orientation sessions, because really before all anyone would have to do is fork the repo and do a couple things like turn issues on and do one other thing, and then we were like, you're a study group. But we didn't have a really good way of tracking or following up on people, and we didn't necessarily have a way of communicating with them. We had forum, but it wasn't particularly active. So now we have the study group Gitter chat, which we're trying to kind of promote. Yeah, and also we're like starting to ask people, at least from the orientation sessions and a little bit in the on the study group calls, we're trying to encourage people to post like what their study group does each week in the Gitter chat. Just be like, oh, we had a meeting about this.
Yeah.
Oh, cool. Okay. Oh no, so this is Puji from, I believe he's from Indonesia. He just joined the call, so that's exciting. Another person, not Brandon though. Hi, good morning.
Hi.
Can you hear us? Hey, it's good to see you. Can you introduce yourself really quickly? Bruno and Kirsty are here. They're Mozilla Fellows for Science. They're going to be presenting, and we're waiting for Brandon to come off. He dropped off due to connectivity issues. But welcome, and just introduce yourself again for Brandon and Kirsty. Oh, I can't hear you.
Hi, sorry. I talked for like 5 minutes before I realized that you had froze.
Brendan, I think if I'm right, this is Puji. He just got here. So Puji, do you want to just introduce yourself? Oh, it sounds like you're muted. Can you turn on your mic? We can't hear you. We can't hear you. Want to try again? Oh, okay. All right. Do it if you can't figure it out. Definitely introduce yourself in the pad. Brandon is suggesting you make it the mic on the computer, not the headphones.
I don't know why I typed that. Sorry.
So Puji is saying his name is Puji, which we so it's great. It's great to see him here. Brandon, do you want to just finish talking a little bit about
Yeah, sure. Did you hear any of that?
we heard about ontology and how it was difficult for people to yeah.
Yes. Yeah. Well, the big picture is that in this field anyway, at least for earth science folks, it's sort of hard to get your mind around some of the hurdles.
Mm-hmm.
So the study group would be, instead of sort of like for a class or whatever, it's more for the people in the domain or in that research area to try and talk about, their first of all, to talk about some of the hurdles and what does it mean if you model something a certain way, and then to share experiences. So that's what I was kind of hoping for.
Great.
Big picture.
Great. And I am just going to go down in the pad and refresh my memory about Pooji, but I think Pooji normally in the past has come to study groups too. So let me see if I can find his info. He came to some of our earlier meetings. Yeah, okay, he's an undergrad student at the University of Gajah Mada. And majoring in engineering physics, and he's still initiating his study group. So that is Pooji, and it's great to have him here. And he's writing that on line 14, so awesome to see him. Brandon, on line 21, I copied and pasted what I believed were your goals from last time. So feel free to just give us a little update if anything has transpired. I know you've been busy and traveling for conferences, so and I know you'd sent out some emails. So
yeah, no, I haven't. All I've done is try to catch up on the reading.
Mm-hmm.
I'm still only in section 2.
Okay.
That was
Yeah. Yeah, no, I totally know. And this is another challenge of putting together a study group, is just that it's another thing on top of all your other work. So we're super excited that you're doing it, and no pressure, just wanted to follow up on your goals there. And Pooji, if you've made any progress on continuing your study group or getting started, go ahead and put that underline, maybe underline, I'll make a space underline 23 in the Etherpad for you. You can just give us an update, a nonverbal update, and I'll read it out to the group.
Okay.
Great. Oh wait, we heard you. Great. So do you want to just introduce yourself a little more formally and say more about what's been going on with you?
Okay. Hello guys. My name is Puji. I'm an untitled student from University of Mada. Okay. What our club is doing is I'm organizing club in my sensor lab. It's a small sensor in my department, and actually we haven't started the club yet because it is the end of the semester and it is hard for us to start the activity. But in the next semester, in early February, we can start our activity because this 2 weeks is the examination.
Great.
Examination. Thank you.
Yeah, thanks for coming during exams periods. I really appreciate that. Okay, so let's go back to the pad. And so I'm just gonna let you know, and if you'd like later on, you can check out the Etherpad underline 7. We had our study group, Northeastern or sort of Western Hemisphere, U.S. Eastern time zones study group call this morning, and we had Christy, who is a former Mozilla Fellow, speaking about the reproducible methods course, which is actually included. There's a video from Christy in section 4 of the study group handbook. She talks about this course that she created to teach collaborative research methods and data processing and open publication to a small group of graduate students at the Michigan State University. And it's a semester-long course, but you can see there's some links in the Etherpad to an instructor guide, which is pretty much everything you need to know to run the course. They did have a successful publication, and they plus got written up, I believe, in Science Magazine. So the course went really well. They had a data set that was basically gray data that someone had collected but hadn't published. And so they reused this data, did a bunch of research on it, and submitted by the end of the semester, they submitted a paper. They did a collaborative editing of the paper using a tool called Overleaf. And it went really well, and she's running the course again. And the reason why, other than it being a great example of teaching collaboration and open science skills, the other reason why we want to mention it to study groups is that you are more than welcome to take Christy's course. And if you're starting a new study group and don't really know what to do in your study group, it's a great kind of semester-long thing that's like out of the box, ready to work through. If you have folks who have time and want to get a data set, an existing data set, and work with it and see if you can publish something on it. So a plug for Christy's course. Also, there's a section there on our open data training series. And if you look at those links, and I will actually just go back and explore them now. Let's see, pad. And I'm going to go ahead and share my screen so you guys can see this. Just give me a second. Oops. All right. So hold on. I'm going to get this in another window. Hopefully. Just bear with me while I get this going. Okay. So now doing screen share. Whoops. Okay, there it is. Great. So let me know if you can you guys see you can see my screen now? Okay, great. And can you see that I just got disconnected from the Etherpad? Is that the right window? It might be in a different window. Let's see what's happening.
The right one.
Okay, great, great. All right. So as the Etherpad is awkwardly loading, okay, there we go. So Mozilla Science is really committed to open data and open data training, and to that end, we've started to create a series of open data training materials, and Steph Wright and I wrote them, and there's a repository which hopefully you can see. Can everyone see this on my screen? The repository window? Yes? No? You can't see it. Okay. All right. Different window. Hold on. Let me get back to this window. Okay. There we go. Okay. Now you can see it, right? Yeah. Okay. So this is the repository for our open data training program, and we have a bunch of primers, and we're producing more as we go, and instructor guides for delivering those primers. So the primers are kind of like read alone, kind of self-guided tours of just like, it's an intro to open data because a lot of people don't even understand what it's all about. And so this is like why it's just a series of writings about why you would do it, and then a bunch of different stories to back up each of the reasons, and a bunch of challenges and responses to open data, and then a ton of resources at the end. And we're continuing to develop these primers, and you can see on the side in typical Mozilla fashion. Not everything is done, but the primers are evolving as we go. And then also the other thing that's available here is, let's see, let's go back. Is instructor guides. So we also wanted to encourage people to teach other people about other open data in a more interactive way. So in addition, sort of as parallel to the primers, there are these instructor guides, and they basically just take you through the basics of how to run a session, an interactive session on open data. So And this is what those look like. So there's a content outline for a session. It gives you time about how much time it would take to do each element in the session, tips on how to run that session, how to do, so this here is showing you how to do intros. There's a little bit of content that you could potentially put on a slide. There's a little video to watch. Then there's an exercise. So it's just basically walks you through the delivery of a kind of complete workshop on open data. And you can see in Etherpad here that when Steph presented this, she talked about how it continues to evolve, and we're looking for people to both run the sessions and give us feedback on them, and also we're continuing to develop the sessions and want contributors on that content. So, so I just wanted to run through that because I think it's really and also an opportunity for something to do in study groups. If you don't know a ton about open data, you're welcome to use these materials and sort of run through one of those workshops in a study group and see how it feels and discuss that with folks in your study group. So those are two awesome open science resources that we have to offer and that we've created at the Science Lab. And then today, two of the Mozilla Fellows for Science, Kirsty and Bruno, are here to talk about their own adventures in open science and what gets them most excited and about open science, and sort of provide some info and resources to you. And for those of you who don't know, the fellowship is a 10-month funded fellowship where folks have time to work on open science stuff and be involved in the Mozilla community and travel around and do lots of amazing things. And so we're super psyched to have Kirsty and Bruno as our two of our 2016 fellows. So Kirsty, do you want to just go ahead and present?
My screen just froze. I'm going to get my external mouse, which will fix it, which is a ridiculous thing to do. So Bruno, can I tag you in if you might go into this? Thanks.
Sure. So I don't have any slides, but on line 57, I added a bunch of links to the stuff I'm doing. So I'm currently doing a PhD here at St. Mary's, trying to finish it. And I really think there's no other way to do science. It's not open science. And so I try to be as open as possible and try to make everything as reproducible as possible. And some of the stuff I was doing, I started putting it out there on GitHub, and people started contributing to it. And suddenly there was the community around all that code and those tools. And so that's how BioNode started. And so the idea with BioNode is to create tools to bioinformatics analysis in Node.js. And the advantage compared to other libraries out there is that because it's Node.js and it's JavaScript, you can run it anywhere. And so you can reuse the same code to do stuff on a server, but you can also use those tools in a web app, which is quite useful because, for example, if you go to our, if you go to our lab page, so warmlab.github.io, and if you go to the software section, you'll see that a bunch of things we are doing are actually web apps. So it's quite useful when you're able to do some of the analysis, some of the logic in the browser, instead of asking the server to do everything. And the other cool thing is that in Node.js, they have a native implementation of streams, which basically means you can in chunks in a streamable way. So that allows you to do all these data analysis pipelines chained together without creating intermediate files or without filling the memory. So it just processes at the speed that your machine can handle, or your cluster or network or whatever. And you don't have to worry about that. You just build your logic, you chain all your transformations, and then you start piping data. I did a 5 minute a lightning talk at the Mozilla Festival. So if you're interested in this, there's this video. Um, there's also a link to tribe.bio.io, which is a tutorial that has done also at Node.js. So you can go there, see some of the stuff we have, see some examples of how to use the tool. Usually, we try to have each binode module be one tool that tries to do one thing well, and so that you can then combine them all together, kind of the unique philosophy. And you can use them as JavaScript libraries in Node or anywhere. But we also, for most of them, we provide their wrapped with the command line interface, so you can just use them on the command line, which is useful for people that don't want to use JavaScript, and also combine with other existing tools. And we also had this year Google Summer of Code Team that works on a project to build a workflow engine. So it's basically a tool that allows you to combine all these other tools together and write pipelines, workflows in a simpler way, and also allow you to combine binode tools with other existing tools or other command line tools. And the cool thing is that this workflow engine is not specific to biology, so you can use it in any other field. It's just we're just trying to build this data analysis tool that benefits on Node.js streams and on the fact that you can do a lot of asynchronous stuff in JavaScript. So try to be more flexible and more scalable. So if you're interested in contributing to that, there's the link on line 68. On line 69, we have a bunch of issues that are open. We're tracking the waffle. We have a Gitter channel, and also there's a startup in Cambridge. They're hiring and they want to work on binode. So if anyone wants to do that, come talk to me. And so I think doing, I really think that doing everything open sometimes is the way to go. But also, I think this is a good example of how we can benefit from it, because if I had done things in a closed way, all the code I've built is just these scripts that no one will use. And now it became a community and people are contributing to it, and I'm using tools that I haven't, binode modules that I haven't written, so the other people wrote. And so this is a more productive way to work.
So, Bruno, thanks so much. That was great. I typed in a question there below your presentation. I don't know what line it's on. Looks like, let's see. Yeah, on line 75. So you mentioned that you put your code online and then a community kind of formed around it. How long did that take? And did you do anything in particular to get that community going? Like, why do you think... What were things that you did to encourage the community to grow?
So it's still a very small community, and I think might have taken a year or two to form. So things that I did, so I presented, I gave some talks about the binode, I presented some conferences, I organized hackathons to get people more involved. And I talked to other labs, other people that might benefit from it. Having the Gitter channel, having ways that people can reach out, having the website, tweet about it, and also talk to not only to the academic community, but also the developers community, so the Node.js community, the JavaScript community, which actually, for some of the things we are doing, can contribute a lot more than actually the academics. So what's really powerful is when you manage to get, for example, in a hackathon, a mix of scientists and developers working on this. That's when things really speed up.
Cool, thanks. I want to point out too that I think all the things that Bruno just listed are things that you could do to bring or attract interest to your study group. So getting the word out, telling people about it, presenting at conferences, organizing events like hackathons where you bring people together around a certain topic, reaching out to other disciplines, reaching out to people in the CS world who might be interested in contributing their time and energy to teaching. So all this stuff, I think, transfers well to study groups. And I think also Bruno has some really good materials with BioNode.js, so that exploring this set of tools could also be a good study group activity. So thanks for that. Does anyone else have any questions? Let's see. Don't see any other ones in the pad right now. Yeah, okay, great. So type them in there if you think of them. And then Kirsty, are you back and functional? Oh, yeah. Oh, was I muted that whole time? Okay, so wait, that whole entire time? Okay, oh my gosh, all right. Okay, great. Yeah. So it doesn't look like there are any. Kirsty, do you want to jump in and talk? And if anyone thinks of questions for Bruno, you can put them there in the pad, and he'll answer them as we go.
Yeah, that sounds great. So, my interests kind of really overlap with a lot of the stuff that Christy and Steph have built their open data guides around. And then it's sort of specifically, I really care about reproducible research. So let me just see if I can share my screen, and we'll see if this works out. But basically, the slides that I'm going to try and show you screenshot. Okay. PowerPoint. So can you see my PowerPoint here? If I go like this.
Yes.
Yeah, good stuff. Okay. So this was a talk that I gave recently, and I was making a distinction between reproducible and replicable research. And basically, if I'm just going to sort of scroll down, the links to these slides are on Figshare, and you're super welcome to like use them in a study group or dive off them, whatever you want to do. And basically, what this slide here is talking about is that if you have some sort of research question. So I happen to work in the Department of Psychiatry at the University of Cambridge, and I'm interested in how the adolescent brain develops. And I'm particularly interested in understanding why many teenagers experience their first episode of depression or schizophrenia when they're around about sort of age 17 or 18. And the analyses are really hard to do, right? There's lots of data. It's difficult to acquire MRI, magnetic resonance images of people. There's sort of big differences between people, and we're trying to look for sort of quite subtle differences as they get older. But the most important thing to me is that for whatever question you want to ask, I want to ask, you, meaning you or meaning anybody else, should be able to have access to the data and access to the code and reproduce exactly what I found. And that, to me, is the absolute bare minimum. If you then take that same code and you have different data, so let's say you take my code, but you have your own data at your institute, now you have replicable work, and you find the same answer. Now you have replicable work, and that's really important because if you want to try and understand something about a person, well, any person, you kind of need the research to not be really, really specific to just those, let's say, 100 people that live in Cambridge that came in for an MRI scan in Cambridge. You need to know whether that's going to be meaningful for someone who lives in the United States or someone who lives in a different country or has a And then if you then, there's also one of the things about sharing code is that the little decisions that you make along the way when you analyze complicated data make a difference to um, the results that you find. So if you if you choose to make one assumption in one of your processing steps, that could actually change the result that you find. But it shouldn't do. It's just because two different code packages are making different assumptions. So what I'm calling robust down here is if you use different code that should be asking the same question with the same data and you get the same results, then we know that there isn't something sort of particularly special about that code. And then finally, if you have different data and different code, but you still get the same result, well, now I would say that means you have a generalizable finding, and that's something that could be useful for people in government or people who are working to support young people with mental health problems, or sort of whatever it is. It means that it can be generalized to a larger community. So this is sort of this is what we want, this generalizable, because we want to make a difference. We want to try and understand something about brain development. But this, reproducible, is the bare minimum. This is like what every study, as a minimum, should be doing. And one of the sort of scary, I think, scary sort of truths about most scientific research is that it is not the case that work is reproducible. So you find a scientific paper, you read it, you think, gosh, that looks really cool, but you have no way of checking the work. And then, if I can skip ahead a little bit, I've got a slide here that talks about different barriers to reproducible research, and a lot of them are quite academic, so I don't know, therefore they're sort of like a lot of these ones about not considered for promotion or held to higher standards than others. That's really for if you are currently doing research as a career. But if I skip down, this one here I think is the key one that I was going to try and answer with the rest of the slides, that you do need some additional skills to make your research reproducible. And that is kind of what I would hope the study groups are going to be able to do. So let me see what I say. So I think I say start small, and one of the main things is like there's a really cool website called protocols.io that just allows you to like write down exactly what you're doing. It's not actually coding, it's just writing down exactly what you do, but it's super valuable. But if you do start coding your analyses, my main tip here is that comments are your friend. That the main person that you are likely to be collaborating with in the future is you. Is in a year's time, you're going to look back and be like, what was I doing here? And I have like a little sort of tip here that you should aim for about 40% comments in your code, and that's just a really good practice. And you should, if you borrow some code from someone else, and this is what Zana's been talking about with some of the resources that are already available through the Mozilla Science Lab, if you find something that like doesn't quite make sense to you, or you're sort of like, oh, it makes sense now, but it took me a little while to get there, put those comments in. It's a really, really great, it's a super helpful way of making a difference and doing open science. And then, what do I say? And then the rest of this talk is talking about some really cool tools in RStudio if you want to do some stats. You can use Python, and my top tip for Python is that you should install Anaconda rather than trying to install it natively. And then this is a really cool set of, it's a Matplotlib has a little gallery that allows, not little, it's huge actually, that allows you to click on a figure, and it helps you, it shows you the code that makes that figure, and you can make it. And then this is a really great way of you to sort of edit that figure to use your own data, or to change the color, or to do something like that. So it's a really nice way of getting started. I'm going to skip over the Jupyter notebook, but if anyone wants to ask me questions, I'll come back to it. This slide was talking about asking for help. Stack Overflow is basically where I learn everything about coding, because I'm not formally trained in writing any code. The MWE stands for a minimum working example, and it's totally fine to ask questions, but if you ask questions that say, it doesn't work, and then you just sort of leave it like that, that's not very helpful and it's very difficult to answer. So one of the things that I think would be really helpful for a study group is to learn how to write minimum working examples so that you can ideally recreate the problems that you're having, share that code with someone, and you will find that there's tons and tons of helpful people that will help you out. But if you do a little bit of work to make it easy for them to answer your question, that's a really great, it's a really useful skill to have, and it also sort of contributes to the community. So you don't have to be an expert to contribute, but you do maybe need to put a little bit of thought into it. And then I have a little bit of overview on Git and GitHub, which I'm definitely not going to go into because that's an awful lot. And I have a little slide at the end here that just says like your community is really important. So reaching out and getting people to help you, and you already know that because you're on the slide. So I'm going to come back. I'm going to stop presenting so people time. And I hope that was okay, but I don't have to take any. Oh, sorry. The other thing that I put in the Etherpad is just the project that I built up at the Mozilla Science Lab's Working Open workshop, the WOW, in February of last year, is the STEM role models project. And the main thing I did that, the main reason that I built that up is because I care about diversity in science, but also because I didn't have any. Ooh, am I frozen? Am I okay? No, good. All right, sorry. But also because I wasn't allowed to share any of my work until it was published, which happened in the summer, and so it allowed me to like build up and sort of show and practice my skills without upsetting the people that I work with, who maybe are not the biggest fans of open science. If you heard that, by the way, that's my dog. Okay, I'll stop.
Thanks, Christy. That was great. I especially liked that really nice matrix where you showed the difference between reproducibility and replicability. I think that is so powerful, and that particularly that point on the difference that code can make, because I just don't think people quite understand, and certainly in the world of in the non-research world, in the layperson's world, among the general public, people just think that science, when science is published, it is facts, and that there's not much that that's questionable about it, or that there's not like a process by which the science is made, you know. And so I think showing that is so important. I am going to put in the Etherpad a little space for questions for Christy. And we're seeing a lot of awesome questions and conversations below Bruno's section. And so, sorry, Kirsty. And so my question for you, just really quickly, is you said that, can you guys still hear me? Yeah, okay. So you said that at first you're, the position that you're in now, previously this summer, right, you couldn't show any of your research. You had some pushback from your advisor or supervisor about sharing your research. And actually that's a really nice segue into another discussion that we'll have in just a moment. But I'm wondering, like, so, and it sounds like you used the STEM Role Models project to get your hands dirty and just sort of start to do some open science stuff when you weren't when you were sort of being prevented in other areas. So can you talk a little bit about what it was like, or other small ways that you've tried to do open science stuff in your lab or within your research group, and what it's like to get started? What are small steps you can take if you're not ready, if you can't jump in on open right away?
So the main thing is that reproducible working does not require anything open. So it's better if it's open, because most importantly, you should be able to check what I've done. Mm-hmm. But actually, the most important person that you're working with is yourself. So I was doing reproducible because I had written code for everything. I actually, one of my like particular sort of special things is the things that I really care about is that the figures are actually made all the way from the original data. So I write code all the way down to all the analyses and then also make the figures, because in a lot of neural imaging, what you see is that people basically do complicated analyses and then just like screenshot and copy and paste that. And there's this word provenance, which I actually just learned about 6 months ago. It's basically what it means is that you have kind of a history of where that piece of data or figure or code or something like that, where it came from. And if you just like screenshot and then say this as figure one, it breaks the provenance completely. You have no idea where that picture came from. And I have also seen a lot of people make a lot of mistakes. And I make a lot of mistakes when I do things like that. So what I did with this project that I was working on for a long time was basically do all of this reproducible stuff. And I shared my code. Like there's a piece of code that I wrote to make brain figures. And it makes me so joyful because I shared that with the people in my lab. And very often when I come up on, let's say, a Monday, because we have lab meeting on Tuesday, and I'll walk into the lab and see everyone making these figures because they have to show what they've been doing in lab meeting on Tuesday, and they're all using my code. They're all showing all of these different figures jumping up. And it makes me really happy. And so I was doing reproducible work and I was sharing code locally with people that I knew, but I wasn't necessarily, I didn't think anyone outside of the group knew that I was doing that. You can still get all of the skills. And then when the paper was published, I made it all available, and now I'm doing it.
That's great. So along those lines, we just have a little time left over for discussion. And so I wanted to underline 86 in the Etherpad. There's a bunch of questions, and so I thought we'd do just about 2 or 3 minutes of silent Etherpadding on how open science is viewed at your institution or your lab, what practices, open science practices might be easily adopted. And I think Kirsty's point about reproducibility is a really good one, just starting there. And then what are the biggest blockers for going open? And Kirsty and Bruno, feel free to just put some data points in here as well. So let's do about 2 minutes of quiet ether padding, and then we'll come back and have maybe a little discussion. Does that make sense to everybody? Awesome. Okay.
I just got to plug my computer in. I'm coming back.
Okay. So we have some good comments starting in Etherpad, and thanks to everyone for typing in there. I'm sort of curious, like, Brandon, you said that open science just isn't considered at all in your lab or group, and I'm wondering why you think that is, and then if other people have suggestions for sort of how to start that, best ways to start that conversation. So Brandon, can you just talk a little bit about like?
So I'm talking about two groups when so I'm merging the comments sort of for both. So the first one is the sort of semantics community in geosciences, right? And the second one is at CABI, um, plant-wise farmers. So at the part I didn't mention, the part I was talking about when my internet cut out, was at CABI we have plant doctors that work in all over the world, and they help people assess what's wrong with your plant. So if it has some fungus on it or something, that people can bring their plants in and say what's wrong, and then the plant doctors look at it and say, okay, this is what it is. You need to apply this fertilizer. You need to water more, or whatever the problem is, right? Or sorry, whatever the solution might be. And so I work on primarily those projects, and both communities are very well. The project, the plant doctor one, is very low tech, and I think so. For that one, it's probably more of a tech hurdle, and just I think if there was a bit of momentum, so which is kind of why I was trying to start the community group, with a bit of momentum behind just eye opening. Really, I think it's just getting people used to the tools and this is what you can do, and this is how it helps, and that kind of thing. And then building the community around the plant doctors so they have to share information. The other community, so for them, I don't think it's malicious. I think it's just, in my opinion anyway, I think it's just a lack of knowledge about in general about how that might work or how that might be applicable to them. And then, and that's my guess, by the way, that's my guess. In the geoscience community, I think it's the old school. Sorry if you can hear that. My 4-month-old's having a party. Yeah. So the geoscience community, I think it's a lot of old school scientists where it's very much the traditional things that we talk about, where I don't want to share anything until I have some result that I can do whatever with, right? So I can publish because publications are important and all that kind of stuff. So in that respect, I don't think it's anything new. I think that's why I put it's denial. Like they know about it, they're just like, you can't put that on GitHub. Afraid of that somebody might comment on it before, Anyway, so that's yeah. Anyway, that's sort of where I'm going when I say some of these things. And I'm not clear about which community I'm talking about when I'm making
Right. Yeah. Kirsty, do you feel like the work that you've done, like what you've been able to show within your lab, has changed minds that might have been previously set against it? Was it just sort of like, okay, you started doing this, and then, or have things shifted at all for you?
So I've made a huge difference with younger people. So it makes me like super excited that basically all of the PhD students in the lab are like completely on board. They're just like, it has to happen. Everything that Kirsty says, they completely agree with. And that's really great. For more senior people, I'm not so sure, but I definitely got to a point where they don't argue with me so much. So they sort of, there's a kind of, if I just do it, they'll sort of like let me.
Yeah.
But I wouldn't say. And then the one thing, let me put in a small caveat. The one thing is our funder, we have a £5 million grant, and so one of the big reasons why I wasn't allowed to share data and things like that is because there are many, many people working on it. Our funder is the Wellcome Trust, and they require us to share the data. And I have to say that I think I am, I'm making headway. I wouldn't say I've made it yet, but I think I'm making headway on not just doing the bare minimum to share data, but to actually like do the very best way of sharing data, which generally means it's documented and rather than just like, technically put online somewhere, but no one can use it. So I do think that I think I've managed to make a strong point that will give us more prestige and also more likelihood of being funded by that same funder in the future. And so that's an argument that I think is currently.
Yeah, that's great. That is great. There's nothing more powerful than like the funder wanting it to happen. So I'm actually curious, Pooji, do you have is there a conversation about openness or sharing data or sharing research processes at your institution? Is that something that comes up? This kind of collaboration or making findings available to others before they're published? Is that like something that people talk about? Can you talk a little closer to your mic? Yeah, that's good.
My challenge is to encourage my friends and people in my lab, small people. But I think if we can do it about open science, I think we can support it.
Awesome. So thanks so much. It's good to hear that. And I do think that's a problem that we hear often is that people are just using the tools that are immediately available and not sort of helping create their own tools or learning to code. And I think the study groups are like a really good place to begin to do some of that. Encouraging people with like baby steps and in a slow way to begin to work with code, data, begin to experiment with some of the libraries that are out there, maybe write their own. So we're so glad that you're here. So we're out of time for today. I wanted to encourage everybody, I guess not so much Bruno and Kirsty, but for Pooji and Brandon, if you want to put down some goals for next time, even if they're small ones, and I know you have a lot to do, so even if it's just like getting through the rest of the reading or maybe writing an email or just feel free to put a goal down at the very bottom of the Etherpad for today. At the very top of the Etherpad, I put a link into the Etherpad for the group 2 call that happened yesterday. And there's lots of discussion in that Etherpad. There's like a big rainbow of conversation that happened yesterday about all these questions that we just talked about. So I encourage you to review that one as well. And we'll have a recording of that call that we'll put online too. We had Tion Brooks and Danielle Robinson talking on that call. So it was really cool. Those are Kirsty and Bruno's colleagues in the fellowship program. So that's all the time we have for today. We are going to meet next week, and it's our last week. We're going to be talking about building community and growing groups. And so hopefully you'll join us next week, and I'll be sending around an email and invite. But otherwise, thanks everybody for the coming on the call, and a special thanks to Bruno and Kirsty for talking today. All right, take care, everyone. Bye.